Thank you for the introduction, and thank y'all for having me here. It's kind of good to be back from at least academic perspective in conferences and stuff again. Feels a little different, so still knocking rust off, right? It's the first big talk probably any of us have done in, I feel like, 20 years now, but either way. I also, when Don asked me to give this talk 2 years, whatever, a year and a half ago, we're looking at it, knowing I'm going to a growers conference and talking about on-farm automation, sometimes to me, that's kind of hard. That's a different task, and what do you look at? What do I want to bring to you guys from that type of perspective? So those of you from Georgia know me pretty well. I feel like I'm a pretty practical, in the field type of guy. So I'm sitting there saying, what can I bring these guys that they feel like, all right, they walk away with something, this is something good, something useful, where's it at? So that's how I spun this talk. So, and at any time, anybody's ever heard me talk, if you want to argue with me during the talk, you want to ask a question, whatever, we can stop and do that. You all know that. I'm pretty laid back. And just to clarify, if you see, somebody said this was a Florida tie earlier. It's not. If you get close enough, it's got crabs on it. I figured, we're at the beach. It's one of the few times, no offense, Scott, or some of the Florida guys, right? It's got crabs on it. We figured go to the beach. It's one of the few times I could wear a tie with crabs on it. So either way, let's jump into this and talk about it. I titled it A Vision for Farm Automation in the Future. So when we get to the end, we'll see if I address my title or not, and see if we've at least spurred some discussion. So again, interrupt me at any time, we can talk about it. So first thing I want to talk about, if we're talking about on-farm automation, how do we define that? And so before we get too deep into that, I want to ask y'all a question. How many of y'all have automation on your farm today? See a couple. All right, so that's good. I see 3 or 4 hands out there. A couple people say some stuff, so maybe not. So maybe it depends on the definition that we use for that. Maybe I should re-ask that question after my talk. We'll come back to it. So when you hear the term automation, maybe this is a better one. What do you think about? Right? When I hear it, this is me. If somebody asks me to give a talk about automation, the first thing that comes into my mind is robots, or completely autonomous control. We're not out there anymore. We're kind of like the video you showed, we're able to control everything from somewhere else. But I take a different definition, I think. Instead of looking at it from robotic control, or removing humans from the full process, I say it's kind of a control or task or function or something out there, right? So let's approach it from that definition for a minute, and then we'll revisit. It's touchy. So back to my definition, I don't think that automation and robotics are the same thing. So that's the first thing we need to do, at least in my mind, and maybe y'all have already separated those two, but let's separate robotics from automation for at least my talk. You can put them back together after this talk, but I would say if not, let's separate those two terms in your mind for right now. So when you hear automation, let's not automatically go to robotics. That's part of it, but it's not the end-all, do-all, right? So it's easy to lump in the same category. And so let's talk about some of the purposes up there. I'm not sure if all y'all can see that. I know there's another projector back there, but I'll go through it. One thing, an easy one, replace humans performing repetitive or dangerous tasks, reduce labor requirements, of course, depending on what we're doing. I think one thing when I talk to, especially, and I know a lot of y'all are not in this market, but if you're in a specialty crop market, a lot of times we want to reduce labor requirements when we're there. Because we're in a specialty crop market, we're using a lot of labor to do harvest, to do sorting, to do some of these other jobs. So, if we can reduce some of that, that really helps. For us, I think specifically, we want to make our operation more efficient. If we do, I'm going to touch on this, I got a slide or two later, but make it possible to change management strategies. Of course, incorporate new technologies. If we've got time-consuming tasks or something else that are going on, right? If we're paying somebody 12 hours a day to go hand weed a field, right? Let's go back to the See and Spray. Man, and we've been there, right? All of us have been there. I still see it. Last week or week before, I was driving around Georgia and saw crews going through fields hand weeding. Eventually we've got to get beyond that, right? We've got to get, we're not paying 10, 12, 15, 20 people to go walk these fields to get stuff out of them. So there's other solutions to that. It's gracious, I got to quit pushing it too hard. So what typical operations have the opportunity? So let's step back. From your farming operation, I asked that question, where do we have an opportunity for automation? Again, don't think robotics right now. Step back and think automation for a minute. I said field operations, for example. So I've split it into field and process, and then we can probably sit here and nitpick and split it into 10,000 other things if we want to. But tillage, spraying, planting, fertilizer, irrigation, harvest, anything we do in the field, right? I think anything. And I'm going to touch all those and say, here's where we can bring automation to this. Here's where we can become more effective, more efficient with these. And then if we're on the processing side, of course, sorting, grading, comes back to quality. If we're having to size different stuff, packing, transporting, on and on and on, right? Any I missed, it just sits on the top of your mind. Come on, y'all can't be as quiet the whole time. Joby and I have this pact. If you're not going to talk, we're going to keep going around and around and around until like 2 o'clock, right? There's no lunch. So just because we're ahead of time right now doesn't mean you'll get to lunch early if you don't talk. All right, so again, I like to step back. So let's step back to our basic operations for a minute. I told you I wanted you to walk out of here today saying, all right, I'm either am doing this, or I'm thinking about doing this, or I have this and I'm not utilizing it to the full potential. You know, that's maybe the 3 questions you can look at on your farm. So what are the opportunities for automation without removing an operator, without going robotic again? I want to, again, differentiate between those two. Let's revisit each one of these that I just mentioned and see where we can use some of those. And so the first thing that I said, most common type of automation is what? Auto steer. So let me re-ask the question. How many of y'all are using automation on your farm? Guarantee every one of you, if you're a peanut grower, you're using that, right? If not, you should be. I think that's one of the first proven technologies from that perspective in peanuts that paid for itself very, very rapidly, usually in one season, right? And in a low number of acres. That's been shown on multiple studies. So I want to talk about auto steer for a couple more minutes. And the reason I call, you did a very good job of setting up kind of the life of auto steer through and then where that moved and where that came from. What auto steer has really done for us is made it available that now we can perform other operations in that tractor without having to focus on specific driving, right? That's the simple basics of it. But it's also done some other things for us. It's made us more efficient, first off, because usually when I talk to somebody that's went from not having auto steer to having auto steer, what's one of the big things they tell you? First thing they tell me is they've increased acreage. Like if you're monitoring on an acreage counter or something like that, we've increased acreage. Why is that?
Feel free to yell it out.
Do we actually increase true farmed acreage? No, we're still farming the same field, but what happens? We better place the product, or we become more online or more effective in that single field when we're making those passes, right? Human error tends to do what? We're going to tend to narrow those passes a little bit or overlap a little bit when we're doing an operation. So usually we're going to end up being more effective within that field range or farming that area more effectively or to its extreme borders. And there's a whole other thing, if we want to talk about some of the high-tech turning to capabilities and some other things that come with auto steer. But first, I call that a type of automation, right? We set that system up, we let it go, we let it do its thing, we let it move forward. To me, that's probably one of the foundational automative technologies on the farm that is allowing us to take all these other steps forward. All right, so spraying, we just talked about a little bit of spraying on there. I highlighted it here. But we've got spray control systems that do so many things nowadays that you do not have to worry about, right? You set that system up, get it calibrated, tell it what you're doing, and then you kind of just sit in the cab and drive that sprayer. Or if you've got auto steer on the sprayer, what do? You engage the button, you sit there and read a book, you sit there and listen to a podcast, sit there and, our younger farmers now Snapchat all day or whatever, the TikTok all day in the tractor, whatever it is now. So basically my point is now we've been able to set this system up, become more effective, more efficient with all these different technologies. They're sitting there on that sprayer that have a feedback system on them, right? It's almost now that we cannot operate without that flow meter going back to that control system. If we use those systems, we're down. We feel like we're down for a while, right? And so we've become pretty reliant on some of them. But what do? They do a really good job when we're looking at making these applications that we may not have been able to do before. So I did really quick, I tried to highlight some of the most current new technology. I put the See and Spray in there. You saw that was released in 2021, a new technology. I think it's a really cool partnership that they've developed and what's coming out of it. So planter technology. So talk a lot about planter technology. I do a lot of research on that. We'll go into a couple different pieces on here. But when we look at placing the seed in the ground, it's not so simple as just going out, setting a depth on the planter, and rolling and planting. And any of you, I'd hope, would agree with me on that. Peanuts are a pretty resilient crop, right? They're a large seed. They have decently high vigor. But from every work that I've done with them, first off, we have a problem with seed quality sometimes, or splits or other issues. Our overall germination is a little bit lower on peanuts than it is with some of our other crops. So anything we can do from the mechanical perspective to maintain that emergence level, we better do. So we better take advantage of anything that we have on this piece of machinery, because if we go out and we have a poor stand at the beginning of the year, that does not set us up for a successful season no matter what. To me, this is one of the most important pieces of equipment, because we don't do a good job here, we've set ourselves up for failure for the rest of the year. So the planter is a very complex machine. We've got a lot of things going on. I've only highlighted 3 parts of this, and I would say the 3 parts that are really looked at automated control right now: the metering system, downforce control, and then depth control. That's kind of where we're at and where we're moving to in the future. And so some of it was, make sure I didn't skip a slide. Yeah, I did. I slept like 3 slides with that one. The metering system, if we look at it, so we've got 3 or 4 different types of meter driven system, right? Of course, we have manual or ground-driven meters, but if we move beyond that, we went through a phase where we had a lot of hydraulic control systems. We still see those, but not as much. We've moved mainly to electrical control systems on our seed meters now if we're going advanced. And a lot of times we've reduced the size or changed the shape of that seed meter due to that. We've been able to redesign that planter based around that new seed meter, not needing all those gears, change sprockets, everything else in that row unit. And then another thing, a lot of research we've been doing recently is really looking at the seed delivery systems. And so you, of course, have a gravity tube, but if we move beyond that, you've got a speed tube or a brush belt. And we've done evaluations of moving that seed from the meter to the ground and what kind of speeds and stuff we can travel at and what that can actually do for us by implementing that type of technology. All that technology, there's nothing you do on it, right? You just learned from Chad that as you're out in the field, what is it doing? It's monitoring these systems the entire time. You tell it what population you want, you tell it where you want to set, and then again, we go back to it. You set up your auto steer and you let the system run and you watch and monitor it and make sure it's doing what it's supposed to do. And optimally, it's placing that seed where it needs to go. Or in this case, if we're looking at strictly metering, it's hitting the target population that you want to hit. All right, so next is a downforce control system. That to me, it's hard to say. I could say one is more important than the other, but if we take in one of these systems fails on us, we're sitting dry in the water. But if we look at a downforce control system, originally we were either no downforce or spring downforce. So those first 2 systems on the left, we moved to pneumatic downforce control, and I think we're moving out of that market now. You can still get pneumatic downforce control, but the newer technology that we're using and seeing everywhere is hydraulic control, and so there's a bunch of different types of hydraulic control on the market, whether OEM or retrofit. The benefit of those is that now we can really do up or down force. We can match the soil condition to where we need to be at downforce so that we can optimize our seed depth, basically. So I think these systems are extremely critical, because I think no matter where we set our depth on our planter, where we set our seed meter, if we're not applying appropriate downforce to get that seed to that depth, we're going to have a lack of emergence and germination. All right, then seed depth placement. And so there's a lot of cool technology out there now. In this case, I just kind of highlighted Precision Planting, Smart Firmer, and Smart Depth System. So the Smart Firmer is a sensor that we're putting behind the seed out there, behind your opening disc and your gauge wheels, that we're monitoring about 5 or 6 different parameters as we plant in that field, and then we use those parameters as a feedback loop. Currently, at this point, most of that feedback needs to be done manually. So you monitor that screen and you make a decision. The farmers I've talked to up to this point have told me what to use the Smart Firmer for is when to plant, when to stop planting. So they're using the soil moisture feature on that. But it has a clean furrow feature. It has a couple of has a temperature feature. It has a few other things that it's monitoring where we're out in the field planting that system. Ideally, we have a smart depth control system back there. And so ideally, if we know where we're placing the seed in a particular soil type, soil moisture, soil condition, et cetera, fill in the blank, we've got smart depth control. What could we do then? If we're not placing the seed at an adequate depth that we know maximizes emergence for that particular situation, we utilize that and we readjust our depth on the go. How do y'all check depth right now? Yeah, Joe laughs, right? What do we have to do? We go out probably, not picking on anybody out here, but I'm guarantee you, because I know that's what most of us do, we set our planter for our particular crop, we pull into the first field, we start planting, we check the depth in, and do we check it again the rest of the season for that crop? Probably not. Probably not. Research I've seen and done, both on farm, research trials, everywhere else, the minute we change soil moisture, the minute we change soil texture, list goes on and on, our depth is extremely variable at that point. And so if we don't have a way, if we're not monitoring and or have a way to go back and address that, we are going to see issues in the field. We see issues in the field all the time. All right, so sensor-based fertilizer application. This is one that I think a lot of us academics worked on for a while, and we never really saw this take off, right? It's getting worked on again with unmanned aerial systems, and I purposely stayed away from UAVs here. Joby's going to talk about those some. I didn't want to get too deep into them here, but we thought this was like the golden egg for a little while, utilizing sensors out in the field, developing some sort of biomass or sort of biomass map, in this case NDVI, and then going back and doing application. And so the two sensors or systems that I'm showing you there are real-time systems. You notice that they have some sort of sensor on the front of that tractor, and then they have a fertilizer applicator on the back. So they're doing real-time application. That basically what we have is an algorithm plugged in. As we drive across that particular crop, it sees it in front of the tractor and it adjusts the rate of fertilizer on the back to match what that current crop fertility need is. And so it's going not quite individual level that you talked about, but this particular technology was getting close to that. Again, in my opinion, I don't see as highly adopted. This technology is highly adopted as what I would like to. But again, that's from the academic perspective. I'm sure y'all have the reasons that you've not adopted it and looked at it, but it seemed to be a pretty good and promising automated technology.
Wes, Tuesday I was talking to a fellow from Ag Leader in Iowa. He said they've got the sensors put on the sprayers. They're going over the field multiple times and putting out a little extra nitrogen.
Every time you see.
One nozzle basis out there. He said up through attachment, beyond attachment. He said it's improving yields.
Wow.
Just a little extra nitrogen.
Just little shots where we see that we need it, that we basically hit that threshold, right? So, good. I'm glad to hear that some of that's going on. This is one that I feel like we negate a lot of times, and maybe y'all just say, well, part of his responsibility is irrigation. But when somebody first asked me about automation, I think one of our highest level of automations on the farm at this point is probably in our irrigation systems. Think about what you can do with the irrigation system right now. Here's a good question. How many of y'all can start and stop your irrigation systems sitting in this room? Most people, right? How many of y'all monitor your soil moisture while you're right here making irrigation decisions? I did it this morning. I did it from the hotel room this morning and then told my guys how much we needed to apply, right? We can do that. Now, we can get into, and I on purpose, I'm not a lawyer, I'm not getting into all that of starting your pivot from right now and then running over somebody out in the field, et cetera, right? We're going to leave that for another day. We don't want to talk about that today. We know that that's there. But when we talk about true automation, I screen captured two of our more prominent irrigation companies. So you got Lindsay's Field Net Advisor there to the left. We've been running that system for a couple of years on a couple of different pivots. What I think is interesting about Advisor is we provide it, or it can download a soil sorghum map. You provide it with some sort of zone map under that field, and then that zone map, what you do is we tell it what soil textures we have. We apply the texture with soil water holding capacity, infiltration rate, et cetera. Tell it what crop we're planting, and it makes daily decisions for you with a VRI map. So it creates 2 maps a day, and it'll run VRI over that system twice a day for whatever crop you're running without sensors in the field. So it's running a soil water balance model and then applying VRI. We're actually running, we've got 2 pivots. If y'all are from the Georgia or South Carolina area and wanted to see them sometime, we've got 2 of them on UGA's Midville Research Station that are equipped with this system. We've done research with corn and cotton under it. Another one that I've been working with is Valley's system, their irrigation scheduling system. So we put a sensor out in the field that you can see kind of with their graphic is talking back to your home office. Both of these systems and a lot of other systems are if you notice this one, it's got a picture of a satellite on it. They do collect in-season satellite imagery of that particular field too, if you find something with that useful. For me, the ones we've been doing, mine are smaller plots, and so the resolution's not what I can do in my small plots, but on farm it may be better. But I just think it's pretty interesting on a technology, on a production system like irrigation, on the level of automation that's completely involved with that. That's one, I think, extremely low-hanging fruit that we can put on almost any farm, that we can step back, as we said, from anywhere and manage that system at about any time and do really good hitting our target or where we want to be.
Wes, back up to the fertility slides. How does the fertility sensor work? Could you explain that? I missed it.
Yep, that's a good question. So what we've done from the research perspective, there's been years and years of research done at multiple institutions that use some type of sensor, and I'm just throwing out there because I've showed you two different types of sensors here. You could use a sensor on an unmanned aerial vehicle, any type of multispectral or visual sensor. We've developed basically an equation that we say if we get this particular reading, we've correlated that back to an in-season nutrient requirement. If that makes sense. And so we put that equation in the computer control system on here. And so again, in this case, real time, as it drives across that field and it's collecting that data off of the, whatever crop that happens to be. We can, in this case, we're obviously not going to do nitrogen on peanuts. Nitrogen is an easy one. Nitrogen is a low-hanging fruit. As Joe mentioned, nitrogen on corn is an easy one. And peanuts, there are other opportunities, and we could talk about those to the side if you wanted to sometime. But nitrogen has always been that low-hanging fruit, but it looks at that plant, estimates health, estimates current fertility requirement, and then adjusts the rates based on that. So does that answer your question? Does that clear everybody up on kind of how those work? So it's a computer control system. It's just running it through an equation that's been scientifically developed. Good question, very good question. Harvest, I think this is probably like one of the coolest things that I've seen, and I'll be honest, I'm not as involved with this side as I would like to be sometimes, but you notice both, here's your Case and John Deere, both of those have self-adjusting systems on the combine as you harvest. Anybody have that technology? And I put the Case and John Deere up here, but most of your large combine manufacturing systems do have that, if we wanted to talk about it. I've seen some talks and been fortunate enough to go to some of the conferences in Europe. It's really cool on what some of these systems can do. They're basically looking at your header, looking at your grain flow, looking at your speeds, looking at your loss out the back real time, and taking that decision off of you and making self-adjustments on that combine while you're driving through the field harvesting. So the very simplistic version of that is if we're driving through the field and it notices that there's too much grain going out the back, they're going to make an adjustment there. If we're moving too much material through and we're keeping too much material in the tank or whatever's happening there, we're going to make adjustments. Or if there's something happening at the header, we're stopping up, or something else is happening, there's particular adjustments that can happen through different levels of that combine. To me, I think that's really, really interesting. At that point, back to about any of these other technologies, now all the driver has to do is drive, right? The driver just has to drive or set up the auto steer and let the system move. All right, so now we're going to move back forward and talk about some other stuff, getting into robotics. So now let me ask the question again. How many of y'all have automation on your farm at this point? Everybody, I would think, right? How many of y'all feel like you're using automation on your farm, or maybe can or will use it now? One or two after that? Come on. That means I failed today. Did not do my job. That's all right. I fell a lot. I mean a lot. So it's all right. I'm used to it. But hopefully, I mean, just after that talk, if you've been on the fence, before I get to my conclusions and go through this, while we're still on what I would say my true, practical, take this back home with you, if you've been on the fence about taking a step in your production operation, what I would tell you today after listening to the three of us up here is go back home and evaluate what low-hanging fruit you have on your farm, what could make you more efficient on your particular farm to increase your profitability, right? We can't always increase yield, but maybe there's somewhere we can, I shouldn't use the word cut corners, but we can cut some of our operations back by adopting a technology that helps us do that. So think about that. Where would that be a best fit on your particular operation that you may have not have done it, you're close to doing it, or maybe you already own the technology, but you're not pushing it to this full potential right now. And it's like, hey, maybe I should start looking into this. Maybe I should start doing this. So that's my wrap up of that part. So let's go back and look at robotics for a minute. I feel like if you had an automation talk and there were absolutely no robotics, no robotic control or anything in there, maybe you'd feel like you got gypped before this. So We talked about this before: repetitive operations, dangerous operations, efficiency improvements, replace humans in time-consuming tasks, and then agronomic management changes. So repetitive operations, for example, and I just went and pulled different pictures for you to look at. You can go you can search anything and find stuff online. But crop harvest, for example, I think one of our big markets that we see more of right now, because the scale that it's done on, is our specialty crop harvesters usually, right? Here I said strawberry, apple, citrus, on and on and on. We're looking at a lot of those, some of the robots that look at doing that, moving those. Spraying, we have talked about spraying a lot already. Planting, transplanting, for example, sorting, grading, and sizing of materials. I think when we look in packing houses and places like that, there's a lot of stuff that's going on there that's automated that maybe we look over. That could be vision sorting or quality sorting or something else going on. Dangerous operations. And so I think this is one that we probably see kind of first. If we've just got some stuff that we do need to remove or eventually remove humans from the equation, we want to start looking at that. And so there are autonomous sprayers out there and available. Maybe we've got people out working in the field all the time, and we've got to get away from doing some of that. Autonomous or assisted harvesting trucks, tractors, etc. Reduce proximity to dangerous equipment, reduce strain and fatigue. If there's just some sort of task that's just almost too hard, or you can't keep somebody working on it because you keep having employees go down because it is pretty hard, or fatigue them out. Efficiency improvements, I think this is probably a big one. I would say if you'd asked me to give this talk 5 years ago, I probably would have talked about swarm robots and running 24/7 and all this, that, and another. I strayed away from that today. I think that's something we've been talking about for a long time, but we still have not seen that change quite happen. And so, we can talk about that, but it's not really where I wanted to go with this, or thought we wanted to go. But more precise chemical application, canopy detection, and volume estimation. We talked about that a little bit earlier. We talked about precision irrigation. We're really on the cusp right now, I think, that we could almost remove, I say almost remove the human from the irrigation decision process at this point. We feel like some of our models and our sensors, to a certain extent, are good enough that we can, they can make the decision, send it to the pivot, apply the amount. And that's basically what some of those systems I showed you have done. They just need your final check of approval to say yes, apply it, or no, don't, for whatever reason. Precision planning, and I'm talking a much wider definition than the company or than what we talked about earlier. Precision weeding, for example, from multiple different levels, whether that's see and spray, whether that's mechanical weeding, whether that's any other technology. And you'd think we have lower downtime, hopefully, with some of these. Time-consuming task, if you're doing spraying, we could also do some spot spraying. That's something that some of us have looked into. I've got a colleague looking at it right now. I'm on a project with him at UGA. We're looking at doing some spot spraying with the unmanned aerial system when we can't get into a field, but we've got disease outbreaks in specialty crops and we just need to spot spray. Can look at that, or in this case, you see that one. I thought that's just kind of a cool picture. That unmanned sprayer there in the top right corner. We've got a mechanical weeder in that bottom left corner, and then a spray drone, and you can buy those. And I'm not getting any legislation today. Do your homework if you're going down that route. I'm not telling you to buy one. Just saying that they are available. They do require extra licensors and other stuff for you to be able to fly and apply with that, but they're available. Agronomic management changes. This one to me is a little bit different, and use it for what it's worth. But one thing is like a potential shift to organic. If there's a special organic market, right, then we can do more mechanical operations at a larger scale without having the chemicals in the field. So don't throw anything at me to say, because I'm talking organic in here. I'm just saying this is opportunities for some of these particular equipment. Precision management of inputs. I thought this one was different when we look at I just said different planting patterns. A lot of people have talked about optimization of plant spacing in row crops, right? And so how do you do that, right? If we can automate that system of where our seed discs are at a particular time and make changes, then we can change our planting patterns, right? We might not go in a true row configuration anymore. There may be a more optimal pattern to optimize yield that we could do. This transplanting and plant tape, I think we actually had some producers using it a little bit and trying out some of this plant tape in Georgia this year. They didn't get to do it at the scale they wanted to because of some environmental conditions, but there was some of this that started happening there. And then you might can look at some different crops potentially just because you have different opportunities. All right, so Where do we move forward from here? You know, I don't know. Remote sensing, drones, UASs, I put that in there. There's my one sentence I talked about. That's it. It's leading into you. So on-farm automation, my deal, and I think you may have gotten this from this talk, we're already at a pretty high level of on-farm automation. I think it's just come to the realization we have it, how to implement it, how to use it. Right, we are moving into the future where eventually we're going to see robots out in the field and doing more and more work there. We're doing work right now at UGA on robotic harvesters, robotic replanters, et cetera. So I think that stuff's a really cool technology. Are y'all ready to completely unplug yourselves from the field? I don't know. I don't know if I would be. You know, you want to stay plugged in and know what's going on. So maybe we're a little further from just a true robot in the field, because as a farmer, I think there's something to be said about being able to go out, touch your dirt, get in the tractor, see what's going on in your farm, instead of just completely monitoring all remotely or having something else run every part of your operation. So, you know, I don't know. There's probably a societal change or some sort of change when we move to that, but who knows how far that is into the future. You know, we're looking at it, we're getting close to doing it, we know that it's available and that it can happen. So, you know, how do we want to adopt it on our farm to best help us? I think I kind of covered some of this already. Basically just went through all that. So I don't know how much time. We're cutting it close on time. She gave me the look that I don't have a lot of, I can't discuss too much. I went too long. Y'all have any discussion? I know we're up here for a panel too, and I'll be around. You can pull me aside and say I'm full of crap after this and say I didn't know what I was talking about. It doesn't matter. Any last comments from y'all before I turn it over?
Wes, one of the biggest frustrations that I've experienced, and I see other growers experience, my son's talking to some farmers in the next county, they went from 6-row planters to 12-row planters, and to be on the safe side, they bought them a chain drive planter and they bought a hydraulic drive planter. They had chain drive planter running the first day, and they had hydraulic drive running about 10 days later.
Oh man.
And that's because of technology problems.
Yep.
Somebody get it running.
So.
You know, we running some downforce stuff. You go to planting in the night, and all of a sudden 2 rows pick up off the ground and drop the seed on top of the ground, and you don't know it till the next day. You're not a happy camper.
So you're gonna get me kicked out of here. There's too many industry sponsors out there for me to answer that question. No, what I would say is we're moving so fast with technology, and I don't know if our industry guys would agree with me or not. They can beat me up in the corner. So if I'm black and blue after this, you'll know what happened. We're moving so fast with technology. Sometimes it is really hard. I think for us, I know it's hard for us as academics to keep up with everything that's out there. I try, but there's no way I can keep up with everything. I think it's hard with industry. There's stuff pumping out and changing so fast, it's hard to keep good trained personnel on some of these technologies and to have enough of that personnel out there to be able to address our needs. I think everybody knows that we are time sensitive when we're doing that. It's exactly what you just said. The mechanical planter, we went and ran, and then we needed a week to get everything else because we had downtime with that hydraulic planter, and there's one guy in your region, right, that can come fix that planter. And that's one of our problems. And, you know, again, hopefully nobody gets mad at me for saying that. I think we all realize it's hard. That rapid change in technology and moving into some of this stuff is an issue. I think we're having to try to figure out how to navigate as we move forward into it so that we do have these systems up, ready to go. They can be timely. If they do go down, we can fix them. The other thing on that, Joe, and you know this, is and any of this technology before that chain drive planter, you or NAP or whomever could probably go back there and fix most everything on it. Or you could go to the parts store and buy a new bearing, buy a new chain, buy a new whatever you need. Right now, it's really hard sometimes if a piece of equipment goes down. I've ran into it, you've ran into it. If we need a specialty harness, we need a specialty controller, we need this or that. It's really hard. You can't go to the parts store right now and get that, right? It's got to be either overnighted to you, or even our dealers a lot of times have trouble getting it. And I think we all recognize that that's an issue. So until we see as commonplace that our dealerships are able to almost carry those replacement parts for these systems where we can drive 15 minutes down the road and pick it up, not have to have it overnighted or not have to have it shipped in, it's going to be hard to see full-scale adoption of some of these technologies. That's just what I've seen, at least in Georgia and some of the states I've spent time in. It gets to be very frustrating from my perspective, working with somebody like you guys, and we try to get a technology there, and then there's a failure, and then it's 3 or 4 days before we can get a part to replace it in. And that's nobody's fault in this room, right? We just know that that's where we're at right now, and that's somewhere we've got to have a change eventually. in that supply chain that we can get that addressed a lot more rapidly so that we can feel comfortable adopting that technology and not pushing ourselves behind. All right, so if y'all find me dead in the dumpster, I tried to walk down that line. Anything else?
What about affordability? I mean, how about all this technology? I mean, can everyone afford all this?
So from,
I mean, how much?
So one, I think that's a good question. She asked about affordability of the technology. One, I think scalability is a big thing, right? You got to step back and ask yourself, how many acres am I farming? To me, what on these acreages would make the most sense for me to adopt? I'm not going to be able to jump in and adopt everything if I'm a small farmer, right? Even if I'm a large farmer, I think I got to take it step by step at time, and then say, all right, the first thing I need to do is this. Use the returns that you make off of that to decide that second investment. But I think over time, most of this, in my opinion, is affordable, but it's utilizing it to the full potential. If you get it and aren't able to use it to the full potential, it's not affordable at that point, right? You've got a really high-end piece of equipment sitting there that we're not getting the full function out of. And so it's one, using the full potential. Two, we can't jump in all the way in, and there's a scalability issue to it. And then we've done a poor job on the academic level of really defining that for you guys, right? We've got, I think Joby, you would agree, we've only got a few economists across our nation that really look at scalability of that equipment from the precision ag side, right? And equipment and information that's out there. There's a little bit, but it's not as readily available as some other things, right? It's not like our crop budgets are, like at UGA, we do a great job of crop budgets, right? And production budgets, they're there and ready to go, but do they have all this technology embedded in them? No, so you can't just pull that up and say, what can I adopt on my farm? So that's a good point and really hard question to address.